right, let's begin the square root practice quiz, going over some of these answers we didn't get to in class. So I'm going to start with number 18. I realized I made a mistake when I was talking about this one in class. I took the square root of 4 and I got 4, and that's right here. I'll show you where I'm talking about. Right here, I got square root of 4 and I got 4. I should have gotten 2. And that would have given me a 6 right here. And then that would have given me a 12 instead of a 24. So it should be just 12. It'd be 6 times 2. That would be 12, the square root of 3. Right there, okay? Again, another way of doing this one, maybe that might work better for you, is multiplying across here. And that would give you 6 times square root of 288 over 2 times square root of 6, and then you can rewrite that as 3 times square root of 288 over 6, which I think is 48. 3 times square root of 48, which is right where we were right there, right? And the rest of the work is the same. That's another way of doing that problem number 18. Similarly, I'll just move on to this one since we're here. Similarly, we can do the same thing with 17, where you can multiply across. This might be the easiest way for us to do this. Just multiply across there. That gives us 3 square root of 5 over square root of 7. And then we have times 4 square root of 14 over square root of 5. When we multiply across, we get, I'll write this pretty smaller. 3 times 4 is 12. Square root of 5 times 14 is 70. So 12 square root of 70 over square root of 35. And then I ask myself, do those square root of 70 and square root of 35 have any factors less than them that are perfect squares? I'm thinking 64, 49, no. 36, no. 25, no. 16, no. 9, no. 4, no. So 70 is all good. We're all good and ready to roll. 35, same thing. I think of my factors of 35. 7 and 5 aren't perfect squares. 5 is not a nice even divisor of that. So, or not a perfect square divisor of that. So this is our answer. Our answer is 12 times square root of 70 over square root of 35, which looks like you can simplify that, but you actually cannot. All right, let's go back again and start at number 8. Now that we've dealt with those two couple, just kind of talking about class stuff. 2 times square root of 32. Again, I'm thinking, what are my factors of 32? So 2 times. Factors of 32. I know 16 times 2 gives me 32. So I have 2 times 16 times 2. I can rewrite the 32 that way. And when I pull that 16 out, I get 4, right? So 2 times 4 times square root of 2 gives me 8 square root of 2, and I'm done. Okay? So that's how we do that one. Again, just thinking of those factors of what's inside the square root that are perfect squares. Again, we'll have that list up for the quiz for you. If you need any help with these or anything else for this quiz or anything math in general, please come in before school, ask me during lunch, whatever it is before the quiz, so you can be ready for that. So for this one, I'm thinking, what are my factors of 8? This is a little bit easier one. 4 and 2 are my only factors of 8 that have a perfect square included. So I'll do 4 times, pulling out the 4 becomes a 2, times square root of 2, right? I take the square root of 4, I get 2. So that's the same thing as 8 times square root of 2 as well. Okay, that brings me to number 10. Number 10. In number 10, I'm thinking about, I'm going to erase some of the stuff from teaching earlier. I'm thinking about that 16 and 3 look like they both have the same square root on them. So we can think of those as like terms, just like 3x or 16x and 3x, right? So when we subtract those, we get 13x, okay? So when we're adding and subtracting with a coefficient or a number in front of a number multiplied by a square root that's the same as the other square root, then we can go ahead and think of those as like terms. So number 11, same thing. 4 square root of 6, 9 square root of 6, 1 square root of 6, 4 plus 9 plus 1 is 14 times the square root of 6, and I'm done, right? That's like 4x plus 9x plus x gives me 14x. Same idea. 12 we did together in class, and brings us on to 13, which I talked about with Aiden at the end of class. I talked about with Aiden that when we multiply the square root of 5 and the square root of 5, that's just like square root of 5 squared. So a square root and a square are what we call inverse operations in that they cancel each other, okay? So that just gives it a regular 5. So both those square root of 5s multiplied by each other gives us 5. 3 times 5 gives me 13. That's my final answer. Number 14. Two of these are the same, are kind of like terms, but we got to notice when we're doing these that we are multiplying. So it's a little different. So we can multiply those numbers in front. That gives me 27. And we can multiply the square roots. It gives me just 3. Right? Because we did square root of 3 squared, essentially. And I'm multiplying that by 9. I'm thinking, what's the square root of 9? Is that an even perfect square? It is. So I have 27 times 3 times 3 gives me 27 times 9 is 243. That's my final answer, my final nice round number answer. All right, next one. I have to multiply the numbers in front and then the square roots inside. So 4 times 2 gives me 8. Oops, that's a weird 8. 8, and then square root of 21, right? And then I'm thinking, what is any factors of 21 that are perfect squares? Is 4, is 9, is 16? None of those are, so I'm done. 21 does not have any factors that are perfect squares. Brings me to number 16. So this is going to be just like 17 and 18, but we don't have anything to multiply across with, right? So instead, I'm going to start by canceling these guys off, right? Since these are 2 or multiplication, I can cancel the 12 and 4. It gives me a 3. And then I take square root of 3 over square root of 6, or square root of 6 over square root of 3. I write that as square root of 6 over 3. That's one of the things I can do that really helps when solving these division problems. That brings me to 3 times 6 divided by 3 is 2. 3 times square root of 2 is my final answer. Okay. Okay, then we talked about 17 and 18 already. Brings us to 19. 19 is one where they want you to rationalize the denominator. So you multiply on the top and the bottom by square root of 6, as we always do. We get 6 times square root of 6 on top, which is done. And on the bottom, square root of 6 times square root of 6 is the same thing as square root of 6 squared. So that's just 6. And I see that these guys can cancel. That just gives me square root of 6 for a final answer. Number 20. Again, rationalizing the denominator. Square root of 7 times square root of 7 over square root of 7 times square root of 7. I get these two cancel to give me just 7, right? And then these two cancel to just give me 7 as well. So I have 56 divided by 7, right? And then that, 56 divided by 7 does give me 8, remember? So that is 8. Again, because these two right here just became a 7. So we're doing essentially 8 times 7 on the top to get me 56. Number 21. So I could think about writing this as 21 times the square root of 7 over 3, but that's not as nice of a number, right? So instead, I think maybe we should write it as 21. Instead, rationalize the denominator, meaning multiply by the bottom on the top and the bottom. So I get 21 square root of 21 over 3. And you think, can I cross those off? I can, again, because it's a multiplication. I get 7. I can cancel those. I get 7 square root of 21. I'm done. Again, 21 is a non-reducible square root from that point on. That brings me to 22. I got 22, 26, and 27 left here. Okay, I have square root of 5 plus 8 times square root of 5 minus 8. Okay, so I could think of this as a difference of squares, or maybe an easier way is to think of this as like a polynomial, right? It's like a binomial, so we can distribute twice, okay? So it's just like you're doing maybe some double distribution, which many people refer to as FOIL for binomials. So we got our first one is square root of 5 times square root of 5, which is just 5, right? Because that's the same thing as square root of 5 squared just gives us 5. Then our next multiplication, so that was this one. Our next multiplication is square root of 5 times negative 8 is minus 8 square root of 5, right? Our next multiplication is 8 times square root of 5 is plus 8 square root of 5. Oops, not square root of 8. Plus 8 square root of 5. And then last we're doing 8 times negative 8, which is minus 64. So we have a negative 8 square root of 5 and a positive 8 square root of 5. Those cancel each other. And we essentially just have 5 minus 64, which is negative 59, I believe. Double check myself. There we go. All good. Negative 59. That one's not too bad in the end. Again, notice that this is a multiplication problem and this is an addition problem. Very different, very different. This one, you're just combining like terms. This one, you have to double distribute in, okay? That brings us, and then same thing here, just combining like terms with 24 and 25. Brings us to 26. 26 and 27 are both where we have to figure out, can I reduce this square root and then leave it after that. So square root of 12, I'm thinking 4 times 3. And square root of 27, I'm thinking 9 times 3. And 2 square root of 3, I'm thinking that's non-reducible. So that 4 square root of 3, I pull out the 4, that becomes a 2 times square root of 3. Oops. 2 times square root of 3. And that 3 times square root of 27, because I pull out the 9, I get a 3 on the outside. So 3 times square root of 3 plus 2 square root of 3. Okay, I need to notice a couple things now. 3 times 3, that's just going to give me 9 square root of 3, right? And then I also have all of my square roots being the same value, right? So I can just add those up. So 2 plus 9 plus 2 gives me 11. That's 13 square root of 3. That's it. All that nasty gobbledygook up here just became a 13 square root of 3. And number 27, lastly, I'm thinking, does 10 have any nice reducible perfect square factors? It does not, so I'm going to leave that. But what about 40? 40 does 4 and 10, right? This is looking good. So now I have 3 times the square root of 4 times 10 plus, I got square root of 160. So I'm thinking, well, does that look? That looks like 16 to me. So 16 times 10 are my perfect square factor and my other factor. That reduces down to 7 times the square root of 10 minus, that 4 comes out, becomes a 2. Is it 6 square root of 10? And I'm adding to that 16 comes out, that becomes a 4 square root of 10. 7 minus 6 is 1, plus 4 is 5 square root of 10. That's my final answer. Because 10 is an irreducible square root, right? I'm now done. But let's just go over number 23 again, just because that was kind of difficult for some people. So I think it's faster to write it as this squared, right? Because the parentheses are the same. So we can just rewrite it this way, squared. But you can also work with it when you do the double distribution. So you can like multiply 3 times square root of 3 and all that stuff all throughout, and you should get the same answer, okay? I think this is a little bit easier, though. When you have identical parentheses, you can just go ahead and write that out as 3 square root of 3 plus 4 square root of 2, all that squared. And then you can go ahead and square all the parts and be done. Again, if you have any questions, please come in before school, during lunch, whatever it is. Ask me questions. Ask your classmates questions. Look them up online. Whatever you need to do in order to be ready for the quiz tomorrow. So thanks for watching.